and we're going to go ahead and complete them. And then, once we've completed the ratio tables, we're actually going to go back and write equivalent ratios. Remember from yesterday, equivalent ratios are two or more ratios that have the same relationship. So that's really important for you to understand and remember for today, because when you're writing equivalent ratios, you have to have at least two ratios that have the same relationship when you go back to write them. So just like when we did ratio tables, or we organized numbers in tables, it was basically called a ratio table because the relationship has to match. So if I look at example 1 here, and we have cars and trucks, we have 2 cars for every 5 trucks. And we can recognize that because the table shows us 2 cars and then 5 trucks. That one's given to us. Okay? Then we're missing how many cars there are for 10 trucks. So we're going to take that, look at that relationship of 2 to 5 and match that relationship with some unknown to 10. Okay? So what I'm going to do is I'm going to look at the trucks because we know that we had 5 to start with and we moved to 10. And I'm going to see if I can come up with a relationship to get from 5 to 10. And I know that 5 is half of 10, so if I wanted to go from 5 to 10, I would actually multiply 5 times 10. So I drew an arrow from 5 to 10 and put times 2. The relationship for cars to trucks has to continue to stay the same. So if I'm multiplying the trucks by 2, then the relationship for the cars has to also be multiplied by 2. So I'm going to put an arrow from 2 and put a times 2 on top of that arrow. And then I simply think 2 times 2 equals 4. So I know the relationship 2 to 5 is the same relationship as 4 to 10. Now I am going to look at that last row or column, and I have 6. Okay? Well, I don't know what I multiply 4 by to get to 6. I could figure it out by doing some division and simplifying. Or I can look back and ignore the 4 to 10 column and come back over here to the 2 cars and say, do I know what I can do to get from 2 cars to 6 cars? So I'm going to draw an arrow from 2 cars to 6 cars. And I know that 2 times 3 equals 6. So I went ahead and put times 3 on the arrow to go from 2 cars to 6 cars. And then I'm going to go back to the same number 2 for the 2 cars and come down to the 5, that 5 trucks. I'm going to take that relationship from 5 trucks and go ahead and bring it over to the blank or the unknown. And I know that I multiplied the 2 by 3, so I'm going to multiply 5 times 3 because the relationship has to match when we're talking about ratios. And 5 times 3 is 15. So now I have all of those numbers filled in. Notice each column is a separate ratio. I only need to know one ratio in order to find a missing one. Okay? So you can choose whether you went to the 2 to 5 or the 4 to 10 in order to find that missing point. And then we're asked to write equivalent ratios. So I have to write at least 2 ratios from this table that are equivalent. And because cars is on top, that's going to be my first comparison. And so I'm going to write a ratio from this table. I can pick the first ratio, the first column there, and say there's 2 cars for every 5 trucks. So the ratio would be 2 to 5. That is one ratio from this table. Another ratio I can pull from this table could simply be the second column. When there are 4 cars, there are 10 trucks. So the equivalent ratio would be 4 to 10. And at this point, I have at least 2 ratios that are equivalent, so I technically could be done. If I wanted to, I could actually add a third because this table has 3. And when there's 6 cars, there are 15 trucks. So I can go ahead and write 16 to 15 if I so choose. And if I really wanted to, I could actually extend this table and come up with a ratio that's not particularly right in this table. I could say if I doubled 6 and 15, I would actually extend the table and have 12 cars to 30 trucks. And so then technically another equivalent ratio would be 12 to 30. Again, you only need 2 equivalent ratios when you are listing them. Okay, I have 4, so I definitely did more than I needed. Again, make sure they're all actually equivalent though. So you could pull them right from the table, or you can extend it, but make sure you're extending and mathematically calculating it correctly when you extend. Okay, let's try another one. Let's look at our part B in example 1. We have markers and crayons. We're given that there are 3 markers for every 4 crayons. Okay, I'm looking for how many crayons there are when I have 9 markers. So I'm going to start with the given 3 markers to 4 crayons, and I'm going to go ahead and find the relationship between the 3 markers and the 9 markers. And I drew an arrow, and I know 3 times 3 is 9. So that relationship has to stay the same for crayons. So I'm going to go ahead and draw an arrow from the same crayon under the same column to the same column for the marker, or for the crayons. And I started at 4. I'm going to put times 3. 4 times 3 equals 12. So I know the relationship 9 to 12 is equivalent to the relationship 3 to 4. Okay? Now, again, like I did in the first one, I could come back to the 4 and go to 48. Or I could ask myself, do I know how to get from 12 to 48? And this time I do know how to get from 12 to 48. So if I wanted to, I actually could just jump from 12 to 48. I know 12 times 4 equals 48. So if I know that, I can just draw my arrow from 12 to go to 48. And then I'll just go from 9 to the unknown. And I'm going to do the same relationship, so times 4. And 9 times 4 is 36. So the relationship 36 48ths is the same thing as 9 12ths, which is the same thing as 3 4ths. Now in this particular case, I technically could have also went back to the original 3 to 4. And I could have went from 4 right to 48. And I know that 4 times 12 is 48. And then I would have gone back to the 3 if I chose to go back to the 4, and gone over here and done times 12. And I know 3 times 12 is also 36. So it didn't matter if I went back to the original 3 to 4, or if I continued on from the 9 to 12. I just needed to find those missing values. Sometimes you can continue to jump, and sometimes, like our first example, you want to go back to that first one because you're not sure what you're multiplying to get to the next value. Okay? And I'm not done with this example yet. I need to write at least 2 equivalent ratios. So I'm going to look at this, and I'm going to go ahead and do the second column. When there were 9 markers, there are 12 crayons, so the ratio would be 9 to 12. And then I'm going to go ahead and do the other one that was missing, which was 36 markers when there were 48 crayons, so the relationship or ratio would be 36 to 48. I only need 2 to show equivalent ratios, and so this one I'm just going to go ahead and write the 2. If I wanted to, I could have used the 3 to 4 because that one was given to me and I didn't have to find them any of the missing values. So these are some ways to use ratio tables to organize the data or the information, the ratio, and to continue to find those relationships. But then make sure you're reading directions carefully, because if it asks you to list equivalent ratios, you must list at least 2 ratios that are equivalent.